So these dowel pins, which is the ones that I'll be using in the fixture plate, I wanted to get a good measurement on them and find out exactly what size they are, just for reference anyway, because we're going to be reaming those holes, and I've got a 250 reamer, and I believe I got a 251 reamer, so I just wanted to see where they're at. So I've got 4 of them out of that kit right there. We're going to be using my Starrett number 221 micrometer to get them, see if we can get us an accurate measurement on this pin. Let me get in there where you can see it a little bit better. Now I believe that this mic is 1/10 on the heavy side. So the way that this one works is that you move the friction, the friction barrel right here until you line up the 0 line perfectly in the center, and then once you line this one up, you read your tenths over here on this side right there. Okay, so let me get in there so that I can see it. And that looks like it's lined up there on the probably right about there. So I'm reading 4/10 over here on the barrel. So what that's telling me is I'm going to go with 3/10. So 250 and 3/10. 0.2503 is the reading that I'm getting on that one right there. Let's grab another one. Alright, that one looks the same, so it looks like it's measuring over here on the 4. Once I line the 0 line up there in the middle, you got to keep it there because see how it moves. So 4/10, I'm still calling that 250 and 3/10. There's some more dowel pins right here. These are black in color. They must have been oxide coated. Let's see what they measure out at. Alright, looks like the same thing. We're getting 4/10 on the mic. And I got one more out of the kit there that will measure it also. Okay, looks the same as well. 4/10 on the micrometer. So again, I'm calling them 0.2503. I've got one more mic that we will use for this little test, just for fun. So I've got my Brown & Sharp Digimic, and this one's really good too. So let me put this in the Starrett 206 holder, and we'll get a measurement of that and just try to compare them. All right, we got our Brown & Sharp mic set up in the stand, and this has a digital counter over here, and this is a real unique mic, as in the barrel, this part of the barrel doesn't rotate, just the end of the mic rotates. It's just slipping there on the cast iron plate. But you use your friction thimble on the end right there to make sure that you have the right torque applied to the mic for your measurement, and you can see that the pin is, you can move it around there. Alright, and then so reading that, so each line, I don't know if I can get in there any tighter. Let me show you. So you see the 50, that's going to be 250 thousandths, and then the line just above it is going to be 2/10. Each one of those lines represents 2/10, and I don't know if you can tell, but it looks like it's just on the top side of that 2/10 line. So I'm going to be calling that right at 3/10, kind of like the other mic was measuring there. You can see it a little better there on that reading, how it's above the 2/10. So I'm calling it 250 and 3. Let's see if I can get a repeat reading on another one here, and picking up another one because I know you can't see it in that shot. Same thing, we're just above the 2/10 line. There's another pin. Same reading. There we go. So I think it's 250 3/10 if you ask me. I haven't shown any of this precision type measurement in a while, and I thought you guys might enjoy it. And plus I wanted to see exactly what these dowel pins were measuring out at. So we will do our drilling and reaming over on the granite, not the granite plate, the cast iron plate, and I can use some pin gauges to accurately measure the hole diameter after we ream it. These are the shortest ones in the kits. These are probably the shortest ones I'll ever need to use on here. So these are 3/4 in length. What I've been doing is trying to determine how deep I want to do the holes. So those are 3/4. So we'll probably just split that and go 3/8, 375. About half of that dowel pin right there. I think that'll be sufficient to hold the dowel pin where they need to be. And we're going to go in between all of the tapped holes, right in the very middle of the grid pattern right there. So we'll do the same thing. We're going to drill them. I'm going to drill all of them, and then I'll come back and ream all of them. Using a brand new 15/64 stubby link drill bit there, screw machine link. This is one of my new ones from KBC in my new set. So that'll work real good. So this is about 15 thousandths under the 1/4 inch finish size. We'll use the same technique. I'm going to come down here. I'm going to establish a full diameter on the cut and double check. Yeah, I'm on. So right about there. And I'm going to zero it. And we're going to drill it 3/8 deep. Alright, there's our 3/8 depth right there. Now I'm going to set me a stop so that we can go to each hole and just come down to our hard stop on the quill. Let's for fun see if we can measure what that diameter is. So I've got a couple pin gauges right here. 234 and then 235, and then these are the plus pin gauges, so they're going to be, I think, 1 or 2 tenths over that nominal size right there. So this is a 234. Alright, it fits in there. And then this is a 235. Alright, so it's trying to fit in there. It's pretty close. So that's probably going to be right at the same diameter as the hole is drilled right there. I don't want to get it stuck in there. So probably around 235 is what the drill drilled on. I mean, right on that actual drill size it cut it. Alright, here we go one more time. I'm going to step them off and make our grid pattern. We're going to start with a .250 reamer. I want to cut it with this and see if it's actually going to fit that dowel pin, because I'm expecting this to cut just a shade over, but I've also got a 251. Yeah, so I've got this one and I have a 251 reamer. So if it's too tight for this, we'll just go to a 251 and hopefully that'll do it. Alright, let me clean that up and see what we can find out about that. Alright, we got our dowel pin We've got a 250 and then a 251 gauge pin. So here's a 250. Man, that is a perfect fit. You see it falling down in there. Perfect fit. 251. Nope. It ain't gonna fit it. So it's between 250 and 251. There's our dowel pin. And it looks like it's going to be just, it's too tight for it to slip in there. That's going to be an interference fit, especially if we measure this at 253. So we're looking right now at it's either a metal to metal fit, you know, same exact size, or maybe even a tenth small. So that's going to be considered a press fit right there. We're not going to be able to go with that. So let me try the 251 reamer and see if that's going to work. Hopefully that will give us what we want. It's going in there. That looks like that's what we want right there. That's got a good fit, definitely. All right, that's going to be it. We're going to ream at 251. That's going to, you can barely feel that thing moving in there. So that's going to be great right there. All right, last hole. Same fit on the last hole that we got on the first one. Now we got to do some QC here. Great. All right, I'm happy with it. Very last step for what we're doing here. I'm going to break the edge of these holes. I'm going to use a chamfering tool, but I'm not going to chamfer it deep like I did all the others. All I want to do is just come down and break that sharp edge. I got my tool in there. We're coming down on our stop again. I'm going to run this up. I'm going to run the knee up till it just breaks the edge there. I don't like the way it's cutting. It's leaving an edge. I'm gonna find a different tool. Here you go. Here's a proper tool. It's a Weldon 90-degree deburring tool. This is one of your, they call it uniflute cutters. So let's try this and see if it'll do a better job. Yeah, that's better right there. It's not rolling up an edge. It's got a good sharp cutting flute there. And that's what I want. Just want to break the edge. I don't want to make a big chamfer there. There we go. So we should have our depth set. Let me move to the next one and see how it does. Just want to come down and touch. Perfect. I like it. All right, I'm going to keep rolling with it. Well, there we have it, everybody. We are finally done with all of our drilling, tapping, and reaming, and the top surface is done. I do have a couple ideas for some more additional holes on the side, but it's one of those I haven't really decided if I'm going to do it yet or not, but we might, so I'll get to that later if we do. But I wanted to give you guys a little example of how this thing could be used here in the mill or any machine really, with the different hold down type hardware that you can use. So, you know, we'll start with our 1/2-inch holes, and you can use your studs or a bolt, 1/2-inch bolt, you know, and screw this in there, and then you can have your strap clamps and be able to hold something down just like that. And I'll grab a piece, you know, just there's a little block right here. So if you just had some funky little part that was hard to hold in the actual vise, you can put it up on a fixture plate like this and be able to hold it down and just configure it so that, you know, you line up with your machine holes there for your hardware hold downs. So there's that. There's the 1/2-13, but I want to show you this small kit that Paul had given me a while back that's going to be used on this plate as well. This is the neat little kit that Paul Boulay had given me, and he was building this. It's probably been about 1.5 to 2 years ago, probably about a couple years. He was building a few of these just in small batches, and he was selling them. And I asked him before I actually started filming this if he was still building these, and right now he's not building these. He says maybe possibly later, like maybe next year, he might be able to, but he's got other projects he's doing, so he's not building these right now. But that's his nice little tag that he had sent me to put on the kit. But he gave this to me some time back. I've had it sometime since last year. But it's a neat little kit, and he also developed this for the Saunders Machine Works mini pallets that John makes. So you have these different strap clamps, different sizes that he put in this kit. You got a longer version right here. You got a steel version right here. These are brass, and then this is a steel version right there. There was another style of clamp that he was making also, and I guess he didn't get around to making it. Stainless steel version that had a V on the back right there. And then you've got these thumb screws that go into the back for that holds the heel of the clamp up. So we'll put one of those in there right there, like that. And then you've got other accessories. You got these little brass pads that go underneath the screw right there to protect your workpiece so that the screw doesn't damage it. You got a spring right there that you can use. Just keeps it held up so it doesn't fall down on you when you're working at it. You got some washers. These got some swivel washers right there, flat washers, and then here's your dowel pins. Okay, and then different size bolts, and then also some studs. So what I'm going to do is I'm going to make up some more of these 1/4-inch studs. I'm going to buy some all thread and cut different lengths and just have a bunch of different lengths in here. And just because these are, you know, we got 2 long ones there that you just cut down to the length that you need. So let me show you this setup right here. We'll get a flat washer and a nut. And let's move this kit out of the way. And we'll put our little block up there. Now, I mean, this is something you can hold in the vise. I'm just using it as an example. So you got you a block right there. And you screw the stud in there. Alright, so something like that right there. Alright. Then you take your wrench and you tighten it down, just like so. A little bit easier shot to see what I'm talking about there, but see, you get the idea. So just use these little hold down kits like this that Paul made to hold odd size pieces. So let's take this one out, this little block, and I'll give you another example of something that you could use this kit for. Like I said, just kind of odd pieces. I watched Tom Lipton. He actually used his kit to hold a piece of glass down that he had to do some kind of machining on. I don't recall what he had to do, but it was some kind of little glass globe that he had to modify. But let's just imagine you got something like, let's say something like that. You know, a piece of plastic, a 3D print, and you need to get in here and do some drilling or some milling or some kind of feature like that. You can use this pallet, this fixture plate, to get in here and actually hold parts like that down. Once I get my kit set up the way I need to have it, so you get in there and you put your clamps wherever you need to so that you can hold some odd size piece. You know, this is something like this is a little hard to put in a mill vise or even on the mill table itself, because you just got those 3 big T-slots to deal with. And then this comes in handy, especially when you got these little clamps that you can configure and put around wherever you want. Okay? Or, hell, I got another one right here too. Let's try that piece. So maybe we want to drill us some holes in there so that we can use some drive pins and mount this on a piece of machinery that we just built. But you come over here to your fixture plate and use your cool little clamps and hold it down right where you need to. If you want to set it up on a plane or have some kind of repetitious setup, you know, that's where you come in here and you put you a couple dowel pins in here and move our clamp, and there you go. Now you've got it set up on a plane. You put some more in there so that you could slide this in like a fixture. It's a fixture plate. Slide it in there. Every piece goes into the same spot. Hold it down with a few screws. Do your drilling or milling and pull it out, and then slide another one in there on your dowel pins. So, you know, that's just an example. I just want everybody to understand that maybe don't understand what these are used for. So it's a universal table that you can set up any way that you need to do a job. These are really great for production if you've got a lot of parts that you're going to do, you know, and you can come in here and you don't have to just leave these holes, that machine in there. You come in here and you can put as many holes as you want, or you might have a specific need to put this in here and then one of these holes are not lining up where you need it. So you could just put a hole wherever you need it to get the job done. You know, so things like that as well. So there you go. There's a good example of how we're gonna be able to utilize this fixture plate in the future for jobs that come in here. Well, I went ahead and took it apart so that I could clean the chips out of the inside, this area right up in here. You guys get another look at the bottom of the fixture plate. Just wanted to get it cleaned up, and I'm trying to get this portion of the build kind of to a closure, because I was hoping to get this finished up and get it aired by the time I go to Fabtech up in Atlanta, because I'm going to be taking this with me. Jason from Fireball Tool, the one who gave me this, is going to be there, and he's coming to the meet and greet at JD. So I wanted to take this up there and be able to share it to whoever's there, you know, at the meet and greet, so they can see it. And Jason wanted to see it in person too. So there's probably going to be a couple of things that we do. I've given thought to maybe painting the bottom of it. You know, a lot of guys have suggested that. It would be just the bottom, just this rough casted area, just to kind of help protect it from surface rust, like you see it's already started on it. And I'd also considered maybe drilling and tapping some holes in the side for like a fence, and I would think maybe two sides would be enough if we was to do that. I just haven't settled on that yet. I don't know. I'm sure it's going to be a good feature, so we may end up doing it, but you can also use the drilled and reamed holes for the dowel pins to make a fence any way you want as well. But it may be nice to have something there on the side. But I'm going to go ahead and get this back together. I've been making sure that it was clean, free of dust. I wiped it off with a rag with a little bit of WD-40 on this piece right here, and I've been wiping this off. You can see this is that blue moly that's that kind of squeezed up there onto the surface. So I'm going to go ahead and get this back on here. Just like that. Got a nice precision fit. And I'm going to get it bolted back on. So with those dowel pins in there, that's the reason why I did the dowel pins, is because so if this plate is taken off for whatever reason, you put it back on there, it should allow it to align perfectly square again, versus bolted it on there with just the bolts, and this could be shifted just a little bit, one way or the other. And I'll torque these down a little bit once I can get a hold of it a little bit better. But I did want to touch on another question that we've gotten on this particular fixture plate right here, and that is the material. There was a lot of guys that's kind of asked why use cast iron? What are the benefits between cast iron and steel? And there was even a few guys that said, if you go through the trouble of all this, why don't you just build one yourself out of a piece of steel? That wasn't the point of this project. The purpose of this is that Jason's already developed a nice platform to start with. This is, available as a raw casting, and Jason didn't actually develop this to be used in this manner right here, but you can see that it's very easily used in this manner, which is, for machinery use. The way that Jason designed this and the way he manufactured it, he has his 5/8 holes in there so that you can use, stronghold type of clamps that stick down in there. And he's designed this, and he's got a welding table that he's built as well that he'll be showing at Fabtech, where he's got a bunch of these plates around, a table not quite as long as this, I don't think, but he's got several of these, bolted down to a frame, which allows you to have a modular setup fixture there, so you can put things wherever you want and make an entire fixture for whatever, if you're building bicycle frames, whatever. But cast iron does have benefits over steel. Just think about all of your machine tools, all of these machines that's in here, the shaper, the mill, lathe. They're all made out of cast iron. All of the bodies and the foundations of the machines are made out of cast iron. It's a very stable, dense material that doesn't move a lot. Steel is a lot more ductile, so it will bend and flex and move, and whenever you say you put like a little scratch in it, a piece of, say this is steel, it raises up a burr there, a mountain peak on the side of the burr. It's kind of hard to explain that, but with cast iron, when you get a little bit of scratching in that, it's just very easy to just stone that down and get it down flat again. But cast iron is a more stable material. It's easier to machine, I think. There's people that will argue that that's not true, but cast iron is very easily machinable. It's one of my favorite materials to machine. You don't have to use lubricants on it or coolant it if you don't want to. It's preferred that you don't, so it doesn't get in there in the cast. It's also a very good material for welding, and that's how Jason developed these. It's a welding fixture plate. So cast iron is great for welding fixtures. So if you was to use this for welding, and you're welding and you get spatter on this thing, the spatter pretty much just knocks off of it. You can take a wrench or whatever and just kind of knock the spatter right off of there. With steel, spatter from welding usually sticks to it. It usually welds itself to the base metal there, and then you have to use chisels and grinders and sanders and things like that to kind of smooth it down. Where the cast iron, it doesn't, you don't normally have to resurface it. But it's just a very nice foundation to be able to use cast iron for something like this, okay? There's a whole lot more reasons why cast iron is more suited for this, but most of you guys know I don't try to get too technical on here. I can't handle it. So I try to give it to you in more plain common sense terms, you know. So there you have it. There's my little spill on the cast iron. But just making use of a nice piece that was already casted and then adding my little special touches to it right here to be able to hold it in a machine. And you know, since going through this project, there has been some pretty good ideas brought up that I didn't exactly think about before when I first started doing it. So you can make a base for this a little bit differently than this. Say you can make it a little bit bigger so that you have tabs on it with slots milled in there so that you can use this kind of like a milling vise. You know how the milling vise has the slots for your hold downs to hold it down there? You could do that, you know, make this bigger, just have it bigger and mill it out so that you got the ears on there. You can go in there very easily and mill some keyways in there and have the keys so that you can set it down on the mill table and have it perfectly square to your T-slots. That's another feature that we could easily do to modify this thing later. Mill it and then install a couple of keys. But I do like that idea of having it so that you can hold it down on the T-slots. You know, you'd have enough material there. Maybe out here, have it wide enough so that you can have it out here, slide your T-bolts in there and have a couple flange nuts and hold it down. So that's something else to consider with something like this. So the sky's the limit. There's a lot of options on this thing. It's very universal and somebody can make it any way they want. So I want to go ahead and mention one more thing before we end this, and that is I'm wondering if there's anybody out there that has enough interest in this piece right here. If I was to make a very, very, very small limited batch of these things like I'm doing right here, if there's some people out there that would be interested in buying one, because that's something that I have been considering, is possibly making a few more of these things and selling them. And really haven't decided how I would go about doing that yet, but there's been a lot of people that's been telling me for a long time that my viewers and my fans alike are screaming for something that they can purchase that I have made. And I know that this is not something that I cast myself, but it's something that I machined completely. And if you've been here through the whole series, you know what I put into this. So this could be something that I would enjoy doing a few more of, very, very limited basis, and seeing if there's a fan base out there that maybe want to own one of these that I put together, that I machined. So drop a comment down there and let me know if it's something. It would not be, I would have to probably do another one and figure out how to get it done a little bit quicker, you know, because these projects like this I take my time on. I really do take my time and I enjoy doing what I do. This is not a production thing, but if I was to build a few more, I would probably pick it up and speed up some things, and most likely get the K&T mill involved there as well, probably for milling these base plates on the bottom, but definitely leave the shaper finish on the bottom, the top, and the side right there. That's kind of one of the shining features that I think would be very unique for this piece coming from A-Bomb 79. So we'll see. It's something I'm kicking around. Let me know what you think about it if anybody's out there is interested in one of these, and we might be able to make it happen later on. Okay? Well, we'll be back and do some more to this, but I hope you guys have enjoyed the build so far, and I'm really looking forward to sharing this with the guys up at Fabtech, and Jason's pretty excited to get his hands on it and see it, but hopefully you enjoyed as well. We'll see you again real soon.